Hello and welcome back to compiler programming. In the last episode, we expanded our functionality to include the encoding of call instructions and even created a very simple partial application function. In between the videos, the only small cleanup that I did is I've created these kind of more regular type definitions for functions, because we will need to reuse them a lot more later, and like making them very structured probably will allow to make some kind of macros to help deal with this situation slightly easier. So I just move those definitions here and make them structured as it. So for example, this accepts void or nothing and returns S64. So this is what it is. This returns S32 and accepts S32 and so on and so forth. So this is just something to make my life a bit easier. But what I'm thinking for today is, if we look at our encoding code, it has quite a bit of fix-me's and to-dos, and I think it's time we started to slowly take care of those. One of the main ones that exists is around the sizing of the operands, and this is something that we will need to know anyway later for things like layouting of structs and various other places. So let's deal with that. This means that our operands, besides type, will also need to know their size. So let's make that happen. Let's go to our operand definition. Here it is. And it needs to have a size. And right now we just say that this is going to be a U32 of byte size. I guess that's fine. Okay. The byte size of the registers is something we need to now maybe slightly change. So if you look at RAX, RCX, and so on, these are 64-bit registers, so we can change our macro definition here to just say that it is 64-bit value or 8-byte value, however you want to call it. So let me fix up the macro syntax, that's fine. And now we also need to add another field, which is byte size, and byte size is 8. Now we also will need other byte sizes, namely we want 32-bit versions of the registers for a lot of operations. So we'll need to also add another version of this. So just say we change our define register macro to be something different, and to accept register byte size, and we will put register byte size into here. Also wrap it in parentheses. It's something very important when you're working with macros, that you do that. I mean, in this particular case, it's maybe not very important, but because macro substitution in C is literally just token substitution, if you have an expression here and you don't put parentheses, sometimes it can cause like problems with operator precedence and stuff like this. So it's just a good habit to have, to always put this kind of stuff here. Now the next thing is, we say this is going to be our main one, and we will have defined register 64, And we will do even more magic with micro, where we say that 64 version, we know that it's actually an interesting thing, because so the 32-bit version of REX is called EAX, and I believe 16-bit is called AX, and then there you have AL and AH for 8-bit versions, but these ones only have they have a different naming scheme to them. I don't even remember what the 32-bit version of R8 is called. I don't know. We'll figure it out. For now, honestly, we probably don't even need to worry about these too much, and we can comment them out and make the other one work. So define register. I guess then we don't need this one, or like this. And then we say byte size is 8. Oh, can type 8, 8, 8, 8, and 8. Here goes the same. And then we also said need, at least for these ones, I want to have 32-bit versions that we can reference like this. And this will be 4, 4, 4, 4, 4, 4, 4, and 4. This should not influence at all our our current functionality. So let's try to build. It still builds. Let's try to test, and it still works. So that's fine. But now we at least for registers we have the correct byte size for them. Okay, we also can add correct byte size to our immediate values, because since we know we say they are immediate 8, that means that, for example, this is byte size of 1. Then we have stuff here where this would be byte size of 4, and this will be byte size of 8. Okay, let's do some nice alignment for stuff. For now, this editor doesn't really have thematic alignment, but it will at some point, so for now we have to deal with it. Okay, so immediate values also have now the size, and for stack we will need to specify size explicitly. So we say also 232 byte size, and we'll just directly assign it. Say byte size is byte size. So that will obviously cause a bit of errors because we call stack in a few places. So now declare variable needs to take the byte size, which is U32. It's fine. Byte size. Now we have these declare variables, and we can even do size of And then this is S64, I believe, at the moment. Side of S64. Brace. It builds successfully. It should not do anything to our tests again because we are not actually using that money yet, but we will in a second. Okay, so now our operands actually have their size, and this is all about this fix me. So I might be wrong, but I believe that we need to put rex w prefix if any of the operands is 64 bits, either the target or the source or whatever. I don't even believe that the source can be larger than the target, so it's more or less always target, but I think for this logic it doesn't really matter because we iterate through all the operands. So we even might want to do something like this. If operand byte size is 8, we just say, okay, we need our rex w prefix. And we remove it from here. And we remove it from here. So basically say we don't care about anything else in the instruction. As long as there is this, one of the varieties operands is 64 bits, that's it. We want rex w. Let me recheck again. What does the documentation say about this? Yeah. From what it seems, it basically says exactly that. Okay. So let's see what that does for us. Do we still do the test still pass? And the test indeed still pass, but I don't believe we take advantage of the 32-bit nature of our stuff, because for example here we proxy S32 to S32, and if we look at the generated assembly for this stuff, so this 32, or probably faster to just scroll. Where's this stuff? Yeah, so this function, if we look at the encoding, of this, then you'll see that so this is like this. I believe this is this is sub RSP8 instruction, and this is our move. So FF is the opcode for move, and we're moving from just call RCX. No, this is call. Function return function arrayx. And this is a call, and this is a sub, and we don't want to change any return. And maybe that's a bad example of what we are trying to achieve, because here we just proxy stuff. So maybe let's create one. What that would look like. Actually, maybe make constant S32 is what we can do. Yeah, that sounds appropriate. So here, as you can see, we were previously doing move arrayx immediate 32, and that works just fine because there is such a version of the instruction. But in reality, we don't want the rex w prefix over here. We want to have it raw. So if we now look at make constant here and try to run this, then we have the move, and that move, as you can see, has the rex w prefix. But now if we try to change it to be EAX, I said EX, oh, wrong button, then we should not see the 48 prefix and our code should still work if I haven't messed up anything. F5. Okay. Pum, pum, pum. Let's see what we have. Now we don't have that arrayx prefix, and I believe the instruction is still correct, which we can just let the whole thing play through and see if our tests pass. Our tests indeed pass, so at least we now have this stuff working. So we can refer to 32-bit version of the registers and everything is fine. Good. Now, the next thing that is also has to do with the sizing of the operands and that we need to take care of has to do with the displacement code. So this part, right? I don't actually have a to-do here, but the to-do is more or less the same as we had it for XW, because right now we just assume that the displacement is 32 bits, but for a lot of stack displacements, this is too much. Like usually functions don't allocate that much on the stack, and 8-bit displacement is more than enough. Or sometimes it will even be 0. So like one of the variables will technically always be 0. Like it will be the last variable that we define. So it seems a bit silly that we always kind of use 4 bytes for the displacement. So we should also try to fix it. And instead of just saying mode is S32, we should do something like mode is, well, actually that's fine, but we add just a couple of conditions. We say if mod, no, not mode, if, because right now we have this zip byte situation, actually no, zip byte does not affect, zip byte does not actually affect displacement, so that's fine. Okay. Operand indirect displacement. Maybe I'll put it in the variable S32 displacement is this, and then what I want to do is say if displacement is less than let's start with simple version. Displacement is 0. Then mode should be mode displacement 0, right? We don't need to even write anything. Else, if displacement is less or equal to 1 byte, actually that might not be correct with because we are dealing with signed number, so probably we want to do it differently. So if displacement is less than 128, or displacement is more than 1, I always forget which direction it's bigger. I think it's bigger in the negative direction, like it should be like this, but I'm always not sure. I don't deal with binary enough to have it at the top of my head, but let's just check. So we say minus 128 is 1 and all zeros. Yeah, so this is the smallest negative number that fits, I guess. And then 127. Yeah, this is the largest positive number that we can do. So that's correct. So let's make them both like less or equal, so they are different. Or we can do it simpler. We can convert it to U32 and not. Can we not? Let's just leave it like this. Doesn't matter. Okay. Mode is mode displacement S8. Good. So we now can choose correct mode value. But if we run this code, I believe it will just break. Check. Yeah, that is not working. And if we run the code, it basically says that we are doing something really wrong with our memory. So let's just stop this. And the reason it doesn't work is because now we also need to change this part. Mode. Yeah. We can actually wrap this code and say if needs mode rm and mode is not mod register, then we have some displacement to deal with. And here we can now kind of switch on displacement and say if mode is mod displacement 0. Actually, then you don't need to do anything, so rather do other two. So if it is 32, this is exactly what we were doing before. Else, if mode is displacement 8, then we can append straight up a byte. And we need to cast here to signed 8. And otherwise, we don't actually need to do anything, but it doesn't hurt to assert here and say that mode is mod displacement 0. Button again. Whoa. something did not work correctly. Declared identifier, bunch of errors. Syntax error equals. What? If needs the RAM. I'm not certain what the issue is. Okay. I think I accidentally pasted some stuff into this file, and this is why it's a bit annoyed. Let me check. No. So what's wrong again? Let me try to comment this code out and see what's going on. Okay, so it's this code. I'm writing JavaScript, and that's not like the error messages in CS so bad. It's like, yes, I misspelled the not equals, but giving me 20 messages, none of them actually saying what's wrong, is not helpful at all. Okay, let's see if that works. And it does work. So I think today will be this kind of a small episode. I don't want to drag it too long. We fixed 2 things that would have otherwise beat us later on. And we are prepared to add more functionality in future videos. Thank you very much for watching, and see you next time.